graph over a line of reflection. We're going to talk about linear, quadratic, and absolute value for each one of these transformation pieces. So the first one being linear. And the reflection of the parent function is negative x. That negative in front of the x is going to cause you to reflect. We're going to look at the graphs in just a second. I'm just going to start by putting the equations down. Quadratic says negative x squared. God bless you. Absolute value says f of x equal to negative absolute value of x. So you think about it, it's basically saying the opposite of x, the opposite of x squared, the opposite of the absolute value of x, right? And so that's what we're going to look at when we put these on the graph. So we're going to start with the linear. And on each one of these, I'm going to graph the parent function before we graph the reflection so that you can see the actual reflection and how it happens. So we'll start out with this parent function for linear. Remember, it's an identity function, so it's 1 to 1, 2 to 2, and vice versa, -1 to -1. Here's my now I'm going to put the reflection. If I plug in 0 to this function, I'm still going to get 0. I have not made any type of up, down, side to side transformation. We're just talking about the reflection. But if I put in +1, what am I going to get this time? -1, right? The opposite of x. So if x is +1, the opposite would be -1. The opposite of 2 would be -2. The opposite of -1 would be +1. The opposite of -2 would be +2. So now I have this new line here. So as you can see, this top part reflected down here, the bottom part reflected to up here. Questions? Yes, eventually, like, they'll give you a combination of all the transformations and you're going to graph it based off all those transformations. Instead of having to make a table, the whole point is to be able to do this, that I can look at these equations and know how it's going to look without setting up a set of points.
And I don't understand it. I don't get how did you do it.
Okay, do you agree that this was our original? This blue was our parent function. So if I were to fold this, put a mirror up right here, this red one would be a reflection down here. Do you agree? And vice versa, this blue, the red would be a reflection up here. That's what we're doing.
So they give you the function.
The parent function is always there.
So they give you the graph of the function, right? I don't think.
You have to be able to go vice versa, both. They may give you this and you graph it. They may give you this and you write it. It's an interchangeable type thing. Okay? Alright, so this is the absolute value one. I'm going to start with the parent function. This is the original one we did on the page before. Alright, so to get the reflection, I'm doing the opposite of the absolute value of x, right? So 0 is still going to stay 0. That one's not changing. But if I put in positive 1, what am I going to get out? Negative 1. And positive 2 would give me... All right, still talking about this absolute value. If I put in negative 1, what am I going to get?
Positive 1.
No, if I get a positive 1, but I got this negative on the outside, which makes it
Negative.
negative 1. And if I put in negative 2, what am I going to get out? Negative 2. That's causing this reflection.
So, in this one, how did you find out the blue?
That's the original. That's the one we did on this page. That's this. These are the parent functions.
So it's like-
They don't change.
So you just like put it on like the numbers of the function the numbers are one that you thought about. Like there's nothing that
This little statement right here is what they call a parent function. It is, we're going to do all our transformations from this right here. All we're doing on these upcoming pages is showing if I take this and I transform it by putting a negative in front of it, what does the graph do? If I transform it by adding a number to it, what does the graph do? If I transform it by multiplying something by it, what does the graph do? That's all we're doing right now, is looking how it changes from this right here.
Okay, so they're like functions that come with graphs. So when they give you the function, you know how the graph looks like, so it comes with it, right?
I don't know that I'm understanding the it coming with it part.
Like coming with it, like when you see that equation and they say graph it, you already know how the graph looks like because you got the
Because you have the equation, yes. Or vice versa, if they give you the graph, you know what the equation will look like.
Okay.
Yes.
Okay.
Thank you. Okay. Thanks for the help there.
No.
Okay, here we go. Last one, we're going to look at the parabola. Alex, sit up for me, please. All right, again, I'm going to sketch the parent function. So, if the V turned upside down, what do you think the parabola is going to do? That's it. It's turning upside down also. It's reflecting across that x-axis. So if I plug in 0, I'm getting 0. But if I square 1 and do the opposite, I'm getting negative 1. If I square 2 and do the opposite, I'm getting negative 4. And vice versa on the other side. So I'm getting the parabola. There we go. Pretty good. Reflection there. Questions about reflection. Negative out front is causing it to flip across the x-axis. Yes?
Are all parent functions going to start from the origin?
Oh, such a good observation. Something's going to be going on with that origin, I assure you. Whether it be a starting point, whether it be a turning point, whether it be the vertex, something's going on with that origin, for sure. For sure, for sure. Good. Ooh, look at that deep thinking. I like it. In my opinion, this lesson right here is one of the most important to college algebra and algebra 2. Because if you start really understanding the graphs based off the equations, the rest of the stuff seems to be a little bit easier. All right, so we're looking at next the dilation. The dilation is what makes it either really skinny, it pulls it up, it stretches it, or it compresses it, it pushes it out and makes it a little bit wider, okay? The linear looks like this. What is A representing in this equation here? What is A representing in a linear function right here? The slope, the M. Does everybody agree? M goes before X? Yeah. What does the slope represent on the graph? Yes, but no, not what I'm looking for. What does it represent when you look at the graph? What is the slope doing to the graph of the line? Making it steeper or less steep. Yes, it affects the steepness of the line. Steepness, like it either makes it go up steeper or lay down flatter. All right, quadratic. Is gonna have that A term before it. It could possibly have, I'll be honest with you, you don't see this very much, but they still put it in the text. It could fall as a number within, but again, it's affecting how slender, it's either pulling it up slim or it's pushing it out flatter, where that parabola is concerned. Absolute value working the same way.
Are we going to have a quiz anytime soon about it?
Friday. Every Friday.
Okay.
What's the B?
It's representing just a variable like A. It's just representing the number that's going to either stretch it or compress it. The A is going to happen on the outside. The B is what would happen on the inside if it were on the inside of the function. Okay, so let's look at f of x equal to 4x. I'm going to do these just the same way. I'm going to draw the parent function and then we'll talk about the transformation. Some of you need to drink a Red Bull at lunch. I don't recommend it, but so. All right, so I'm going to draw that parent function again, the linear parent function. Wobbly parent function, but there it is. I'm going to graph just a couple of points. I know that if I plug in 1 here, I'm going to get positive 4, because 1 times 4 is 4. And if I plug in negative 1, what am I going to get? Negative 4.